Hi everyone, we're going to find critical numbers for f. This is number 21. And find open intervals where f is increasing or decreasing. And first we're going to take the derivative so we can apply the test to identify any relative extremum. So when I take the derivative, I'm going to use my quotient rule and write down my denominator times the derivative of my numerator minus my numerator times the derivative of the denominator all over my denominator squared. And cleaning all this up, you should get x squared plus 2x minus 3 all over x plus 1 squared. I'm going to go ahead and factor the numerator, and that's going to give me x plus 3 times x minus 1 over x plus 1 squared. We're going to set this to 0 to find the critical numbers. So when you set it to 0, the denominator cancels out, and you're going to get x equals negative 3 and x equals 1. We also have a discontinuity here at x equals negative 1. So we're going to use all these values to test the intervals where f is increasing and decreasing. And I'm going to write them in order. So my numbers were negative 3, then the next lowest number is negative 1, and then 1. Excuse me, so our test intervals are negative infinity to negative 3, negative 3 to negative 1, negative 1 to 1, and then 1 to infinity. And we're using our first derivative test. So our derivative was f of x, or the derivative of f, is, I'm just going to write out this x squared plus 2x minus 3 over x plus 1 squared. Now, when I plug in a negative number, say negative 4 in here, I'm going to get a positive over a positive. And you can plug that in with the calculator, but it's going to be positive over positive. So that means the sign of my derivative is positive, right? If I plug in 0, say, no, we can't plug in 0 yet. Darn it. So let's plug in, say, negative 2. If I plug in negative 2, I'm going to get a negative over a positive, and this means that's negative. So our derivative is negative. Now if I plug in 0, it's easier to see. If I plug in 0, I'm going to get a negative 3 over positive 1. That's negative. And if I plug in a large number, bigger than 1, say 2, you're going to get a positive over a positive. So this is going to be increasing. So what we can do is we can write this as increasing, decreasing, decreasing, increasing. And recall that negative 1 is a discontinuity. Okay? So what we're going to do now is test our plug-in. So we have increasing, then decreasing. Then I have some asymptote there. Then it's decreasing and then increasing. So I don't know exactly what the graph looks like, but that's what's happening. So To get a min and max, what we're going to do is use our original function, which was f of x equals x squared minus 2x plus 1 over x plus 1. And my critical numbers were -3 and +1. And you're just plugging those in. So if you plug in -3, you're going to get -8. And if you plug in 1, you're going to get 0. So for the first one, okay, so our point is -3, -8. So since we're first increasing, then decreasing, this is going to be a maximum, a relative maximum. And then on this one, our 1, 0, this was decreasing and then increasing. So this is going to be a relative minimum. And that's all. Thank you. Have a nice day. Bye-bye.